Okay, hello everyone. I'm very pleased to give introduction to my research. So my research is the next generation technology for human-centered robotics and automation. My name is Hsien-I from Institute of Electrical and Control Engineering. So let me give a short bio myself. I graduated from the double E from Purdue University. So now I'm the professor that just at NYCU. So I have some professional experiences. You can check my website. Particularly, you can see my website. My website is https double slash arlabtw.com. If you are interested, please just go to my website. And the courses I have taught is digital signal processing, machine learning, robotics, and optimization theory. So here is my lab and my office. You can see the campus environment is so gorgeous. Okay, the building, what I'm located is NYCU double E building. You can see the campus is quite beautiful. So my research focused on three topics. The first one is robot intelligent control. The second one is artificial intelligence and machine learning. The third one is imaging and sensing. Okay, so you can see some of my research field. I work on the human-robot collaboration and novel robotician, and also some robot assembly, lot of industry applications. And also I work on some medical image recognition and hand recognition. This all research around these three topics I mentioned, robot, intelligent control, and machine learning, and sensing and imaging. So these are other applications. Okay, I just give you a quick view of this previous work I've done. And today I just give you one of my current research, which is the robotic polishing. And why we do robotic polishing? Because the labor polishing is very time consuming. You can see from the picture, this lady is working very hard on polishing the wall pieces. So it is very labor intensive. So now we just try why not we just using robots to replace humans to do this kind of very tedious work. So now we have come up with some research in the direction. For example, we have AGVs, we have the like trajectory planning, we have the active force control, so on and so forth. Okay, so we have some different issues here I show here, but I will just go to detail. Let me show you one of these. I call this O2O teaching method. Okay, so O2O method is how to teach a robot to plan the polishing trajectory. You can see we just load the CAD files of the wall pieces, and then the offline software can automatically plan the polishing trajectory, and then we can simulate this polishing work test in the simulator, and then we can just try on the real system. And if there's something wrong, we can also use the haptics control to justify the polishing trajectory. We can see here, we can see left below is the haptics device. So we can use the haptic device to simultaneously control the robotic arm. Okay, I think this video pretty much that. We can see the robot can do the polishing automatically. Okay, so let me introduce another topic is active force flange. What is active flange is used for? Because we know here, let me show you the video quickly, and you can see now we have the raw egg. Okay, it's a raw egg. So we invented this. We call it ACF to polish the egg. So the purpose is we cannot break this egg because the egg is very fragile, you know. So we have to control the force. You can see when we touch the ACF, this device will just have some kind of function of compliant capability. If we touch, you can just push back, but the function is you try to reach to control the desired force. And we can see the left hand side after polishing. You can see we can the roughness of the X surface. You can see here, right? The roughness is very flat. Okay, so we call this, we say it's a ACF, but it involves some adaptive control and some advantage technology. The other one is the AOI, automated optical inspection. The purpose is to, after polishing, we have to check is any defect still on the workpiece. So now we have a camera, we have the light, we have the motor to control this flywheel, and we put a camera to just inspect any defects on the metal. So we can see we have some AI, we have the deep learning model, try to use the state of art, the deep learning model to find all defects on the metal surface. And also we have the digital twin. So digital twin, I think nowadays is very popular. Digital twin, the idea of digital twin is how to generate a virtual version of the system in the simulator. So you can see we have the real robot and we have the simulator, right? So the simulator will do the same thing as the real one does. So you can see this video, right? So you can see the robot is, we can simulate the robot. We can monitor the power consumption. So actually this work is done by my Indian student. Okay.
Wow.
So it's very, so I have a few Indian students. So he is very interested in this kind of research because he was working in the power plant, and there's many simulation in the power plant. That's why he asked me, he wanted to do some simulation. Okay, I said digital twin may be a good, maybe suitable for you, and then I just assign this job. You can see we just simulate the polishing, right? You can see it's this we call the digital twin, right? So this will be exactly the same a physical system, but also we are monitoring the power consumption. The purpose of why we need to monitor the power consumption is we want to reduce the carbon dioxide, because now the global warming is the most important issue nowadays in the world. So that's why we have to very serious about this problem. So finally, let me just show you some remarks. I have some Indian student now, and I have my former Indian student who now working in the industry. For example, they are roboticists, and also the computer, they are working on computer vision. And so I just, I recruit outstanding student or graduate student. If you would like to pursue your master or PhD program, I'm very just happy to support you, and we provide a competitive stipend for you. Okay, their funding. I think that is my introduction. Thank you.